this first example may look a little bit like something you did in chemistry class, okay? A chemist must prepare 350 milliliters of a chemical solution made up of 2 parts alcohol and 3 parts acid. How much of each should be used? This entire section of notes, this is all just equations. Okay, so we're not looking at inequalities. We're not looking at systems of equations. We're not getting into all that yet. We are just doing basic equations, all right? And I know when we do word problems, the biggest thing for most of us is just sitting here looking at this and saying, so where do I start? I have literally no idea. Some people are visual. If you draw a picture, it might help you. Other people have to write it out in different parts or highlight the key words or different things. I'm going to show you a couple different ways to look at this. It's totally up to you. First off, when I go through these, I do look for important pieces of information. What is 350 milliliters? Well, it's the total. Okay, anything that I have adds up to that. That's my total, my answer. Other important pieces of information in this question are what?
2 parts alcohol, 3 parts acid.
All right, so when I'm thinking through a question like this, 2 parts alcohol, 3 parts acid, how many parts total? 5. Okay, so that means if I'm thinking that I have a chemical solution, you'll love my little drawings here. Okay, it's made up of 5 parts. Okay, 2 of them are acid, or 2 of them are alcohol, 3 of them are acid, 5 parts total. Okay, when it says it's split like this, 2 parts and 3 parts, it's implied that they are equal parts. What we are trying to find is how much each of these parts are, right? So one of those is X milliliters. So how could I potentially set up this equation to find out what one of those is? Okay. It eventually will be 5x, but how did he get to the 5x? There are 5 parts. Okay. Yeah. Well, it's like 3x plus 2y, yes, but you can use x's for both. 2 parts alcohol, 3 parts acid, adds up to the total, right? We don't have anything else in this. Now, if you do combine like terms, you're going to go directly to 5x equals 350. The solving part of this is not the difficult part, right? It's the setup. Question? Yep.
You can use X because it's alcohol and acid, so aren't those different things?
They are different things. The key is that that's not representing alcohol or acid. It's representing how much one part is. So in this case, X is representing the number of milliliters of one part. Question? We don't like the fact that I'm using X's for both. I get that. And it's just because all 5 parts are the same amount. So the X is, it doesn't matter that it's alcohol versus acid. What matters is that the parts are all equal amounts. And so that's what your X is representing in this. Now I put it as 2X and 3X so that we can remember how much alcohol at the end. Well, 2 parts of the whole solution, we're going to find that at the end. But hang on to that for just a second. The solving, like I said, of this is not difficult. You end up with X equals 70 milliliters. Essentially, what you have just found is if I take that chemical solution and divide it into 5 equal parts, each part is 70 milliliters, right? Now, how do I find out how much alcohol and how much acid is used? That's where we go back to plug them into these separate pieces. That's why I set up the equation with the 2x and the 3x. This is the amount of alcohol. I think I spelled that right there. And then this is the amount of acid.
So if you had 2 different sides, you wouldn't be able to solve it.
Exactly. If you had 2 different variables, then you're in a system of equations situation. And you need a whole lot more information than that. But this, because the parts are equal, you can represent them with the same variable. So my final answer is not that 70. My final answer is how much of each I do need.
So is it because it says how much of each, that's why you use the same variable?
Yes, and it's because
Say how much of each, you have to say like,
it's because of the definition of the word the parts. If they're telling you the chemical solution is divided into 5 equal parts, that's why you can use the same variable for both. That's all. Okay? So the amount of alcohol is 2 times the 70. So how many milliliters for alcohol? 140 milliliters of alcohol. And how much for the acid? You're going to do 3 times 70, so 210. Now, I may or may not confuse some of you, but you can also subtract from the 350 to find out a different way to do this. It's a harder setup. If you don't like that, you could say X is the milliliters of alcohol, and the milliliters of acid would be like 350 minus X, but that gets a little bit more complicated. So I'm going to just leave it the way it is. Okay. Any questions, problems, lingering concerns about this? Nope. All right, that's the acid. All right, let's take a look at example 2. Example 2 should be a little bit more familiar to us given that we are used to doing rectangular shapes and all that in math. You even have a diagram for this. All right, so what we're looking for here, they've given us, there's a deck and there's a walkway around the deck. And then there's a rectangular shelter in the middle of that deck with 40 meters squared as the area. It says the uncovered part of the deck is to be a walkway of uniform width, which is what they've labeled W the whole way around. How wide should the walkway be? So you have to combine this information that we're given into an equation. All right? I know a lot of different pieces of information in here. So I have to set up something that I know about this. Like I think when I look at these, do I know something about the perimeter of any of these? Have they told me what the perimeter is? Not really a trick question, right? No, they have not told me that. What have they told me information about?
The dimensions of the bottom.
They've told me the dimensions of the bottom, and in the paragraph above, what else have they told me about the dimensions? That it has a total area of what? Where's the area?
Are you talking about the thing on top of it, or the?
Yep, the shelter has an area of 40 meters squared. In that picture, what part of that has that area? The blue part. This has an area of 40 meters squared. So I'm just like going through this, combing through for information, seeing what I can figure out. I know that the area of that blue part is equal to 40. Therefore, I can set up an equation given that. How do you find the area of a rectangle? Length times width. So let's take a look at that blue part that I've kind of shaded in there. What is the length of that blue part? Hunt through that for where the actual part of that. The whole thing is 12. What's the length of the blue part? 12 minus 2w. So that's the length. What's the width? 6 minus 2w. Hello.
Can we have your attendance?
Oh, sorry. I thought I submitted it.
This is for Wyatt Rhodes.
Wyatt.
City roads.
Thank you. I thought I submitted. I did not. Emma Stevens is missing. Thank you. All right, so we said the width was 6 minus 2w. And that is equal to the area, which was what? 40. All right. We've got our equation. Where do we go from here? Any ideas? Multiply them. Good old FOIL. Take a minute on your own papers. FOIL. Let's see what we remember of foiling. And then what factors of 8 add up to negative 9 in the middle? -8 and -1. In order to solve, we set our factors equal to 0. I don't have to set that 4 equal to 0 because that doesn't solve out to give me anything. But I do get 2 answers for W, 1 and 8. Do I keep both? Okay, how do I know which one will work for me? Plug it back in. Let's see if that makes sense here. Like, let's look at the side. If I plugged in 8 for the width there, 6 minus 2 times 8, what are we going to get for the width there? A negative. Are we okay having a negative? No. So we're going to get rid of that 8, and we just keep 1. We're measuring in meters. All right? Questions, problems, concerns? Good old factoring.
What happened to the negative one?
Because when you got your factors here, I skipped this step, but you're essentially setting them both equal to 0. And then when you move the 8 and the 1 to the other side, that's where you get them to be positive. Now, before we look at a couple more word problem examples, let's look at this vocabulary down here at the bottom. This is where we start getting into some of the business stuff. Okay, so some vocabulary that you will need to know. In just business, fixed cost is determined to be the sum of all costs that are independent of the level of production. That's a fancy definition to basically say, this is how much it's going to cost the people to make this, or to produce something. I'm not a business person, so sometimes I'm not going to talk in my terms. What makes sense, and then we're going to go with that. A variable cost is the sum of all costs that are dependent on the level of output. In other words, these costs can change. The variable costs sometimes change based off of if you make more of this, it's going to cost more to make that. The fixed cost is maybe like, all right, so the factory has to buy this machine to make it, therefore that machine costs $10,000. We're going to start with a base of $10,000. Then the more you make, you have to buy more. If you're making jeans, you have to buy more of the fabric. That's going to cost more the more that you make, and so on. So total cost is determined to be variable cost plus fixed cost. Pretty easy. Add the 2 pieces together, you get both. Revenue is, the definition of revenue is how much they're making. Okay, that's the big thing in the business world. How much am I going to get from this? Your revenue, you always find it by saying the price per each item times the number that you sold. Okay? And then profit is the biggest one. How much money are they going to make at the end? You've got this money in. Revenue is how much you're getting in from selling it, but you have to subtract out how much you paid to make it to begin with, because you're not getting that money back. So your profit is total revenue minus total cost. We're going to use that in example 3 to put together our equation for this. Okay? So, Anderson Company produces a product for which, here's where I start highlighting. The variable cost per unit is $6. I just saw that in my definitions. Variable cost per unit is $6. Fixed cost is $80,000. Each unit has a selling price of $10. Determine the number of units that must be sold for the company to earn a profit of $60,000. The fixed cost is $80,000, so they're basically saying to set up to make any of these. Get the building, get the machines, whatever else it is, it costs $80,000 just flat. Whether I make 1 unit or whether I make 50,000 units, it costs me $80,000 to set up. The variable cost means each, let's just say, I don't like saying each unit. This doesn't make sense. What do we want to make? We're going to make, I said this earlier, jeans. So if we say that, if we're producing jeans, it costs me $80,000 to buy the machinery, the sewing, all of that stuff to set up to make jeans. Then every time I make 1 pair of jeans, it costs me another $6. So I make 1, It costs me $6. If I make 10, how much does it cost me? $60. If I make 100, it costs me $600 because the fabric costs money, the thread costs money, the buttons for the jeans cost money, and so on. $6 for each one. Then we sell each pair of jeans for how much? $10. We would like to make a $60,000 profit. So how much do I have to make to figure that out? So let's go back, and we're starting. Anytime you are talking profit, you're starting here. Okay? So everyone just write that down. Profit equals total revenue minus cost. Now we're going to fill in what we know of that. What kind of profit do we want to make? 60 grand. Now, total revenue, I have to go back up in that vocabulary because there are multiple pieces to this total revenue business. Let's go back up here and find that. Total revenue I get by doing this. Price per unit times number of units sold. So I'm going to replace total revenue with that statement right there, but I'm not going to make you write the words. Let's fill in what we know. Price per unit, do we know what that is? 6 times the number of units sold. Do we know what that is? No, what are we calling that? X. All right, let's now figure out cost. Cost also has multiple parts to it. Where do we find that? Up here under total cost, right here. Total cost is found by doing the variable cost and the fixed cost together. Okay, so when I subtract this here, I'm going to put it in parentheses because there's two parts to this. Let's not start with the variable cost. Let's start with fixed cost. We know that one, that's easy. 80,000, that's the second part. Variable cost is how much it costs to make one of each item. Okay, how much does it cost to make one of each item? 6, but you have to multiply that by how many that you are making. Do we know how many we're making? X. We're making X. We don't know, right? So my variable cost right here is going to be, whoops, I did something wrong with the revenue, didn't I? You're looking at me like I'm crazy. This is 10. Why is that 10 and why did I do that wrong? Revenue is how much you are making. The selling price is what you include in that, not what I did there. Sorry. This is your 6X. All right, I'm going to pause here because I just screwed that up. Anything that you are confused about where I got it from now that I fixed the 10? Revenue, remember, is how much you're making, so that's why the selling cost goes there. The making cost goes in the cost. Okay. All right, now, solving this, not super difficult. Where do I go from here? Distribute. I'm going to come up here for a little bit more room. I'm going to subtract 6X and subtract 80,000. Just like any other solving, I would like to get X by itself, so I'm going to go ahead and add the 80,000 to the other side. 140,000 equals 4X. Last but not least, we divide. So when we divide 140,000 by 4, I don't actually know what that is off the top of my head. 35,000. And then technically this is units. I made up that we were making jeans, but. So in order to make a $60,000 profit, you have to sell 35,000 units of whatever you're making after all is said and done. This profit total revenue cost, this is not like we're doing this for one example and then it's never going to come back to see us again. this will be here, okay? So that kind of formula, knowing those 3 formulas there, that's going to help you a lot just going forward, all right? Any questions about that one before we dive into a couple more? All right. Let us take a look at example 4. Another good example of a selling one. Now they are actually selling jeans. Look at this. All right. Sportcraft is manufacturing jeans. There is one typo in this one before I go through it. The cost to the retailer is $60 per pair of jeans. As a convenience, they will attach a price tag to each pair. What amount should be marked on the price tag so that the retailer can reduce this price by 20% during a sale and still make a profit of 15% on the cost? Lots of words. All right, so for this one, another helpful formula to us is that you can determine the selling price by taking the cost per item and adding the profit per item. Okay. So what this is telling us is that you can determine what you would like to sell something for by saying, here's how much it costs me to make it, and here's how much I want to make from it, and adding them together. That's what I should then sell it for. All right? So let's just weed through the words here and find out what of any of this we know. Do we know the selling price yet? That's what we want to find, right? The selling price is going to be our variable somewhere. Let's not fill anything in yet. Do we know the cost per item that it costs us to make? $60. Profit per item. Okay, do I know how much I'm making on each one? 15% of what? It's 15% of what you are selling it for. Or 15% of the 60? Yes, it is. All right, so you are going to make 15% of the $60. That's what you want to make. Now, the selling price business over here. There's something in this problem that we have not accounted for yet. A number we've missed. Anyone see the number we've missed? The 20% business. Okay? We don't know what we're doing with that yet. How does a 20% sale work? You take the price and you do what? Take off 20%. In math terms, what is take off? Subtract. So your selling price is determined by the original price taken down by 20% of that price. In other words, instead of paying the full price, the full 100% price, what percent would you be paying then? 80% of the price. All right. If you do some math on the right-hand side, 60 plus 0.15 times 6 gives you 69. And if you divide both sides by 0.8, you get that the price should be $86.25. So that's the markup that they are taking on that so that you get 15% profit on the 60 and you can mark it down 20% and still make that 15%. All right, 3 more, and I shall be done. Okay, in example 5, this is now an investment thing. A total of $10,000 was invested in 2 business ventures, both A and B. At the end of the first year, A and B yielded returns of 6% and 5.75% respectively. What does that mean?
I made that much more with my money.
A made 6% more, and B made 5.75% more. All right, on the original. How was the original amount allocated? That's a fancy word for split up. If the total amount earned was $588.75. All right. So here's how we're going to split this up. We have two investments. We have investment A and we have investment B. How much did you make overall?
588.
All right, so let's start with what you made. That is what this is going to equal out to. Do you know how much you invested in A? You got 6% of that back, but you don't know what you invested in it, right? If we don't know how much of something, what do you usually call that? A variable, like X. All right? So we're going to start off just by saying you invested, we're going to say this is my investment A. You invested X in A, and how much of that did you make back? 6%. How do you write 6% as a decimal? 0.06. You don't know exactly how much you invested in A, but you do know how much did you invest total? 10 grand. So we have to include that somewhere. I'm going to draw a picture on the, no, I'm not drawing a picture on the board because I have remote people and I got to do it on this. You could, but you don't actually have enough information. So to avoid systems of equations, here's what you're doing. Okay? I'm about to show you this. You have 10,000. Oops, that's one too many zeros. You took out of that 10,000 to put in investment A, X amount. You also took some money and put it in investment B, right? If you took away, math language, X dollars out of 10,000, how much do you have left for B? What's take away mean? Subtract. So you have left for B 10,000 minus X. You're basically saying I put this amount in A, the rest of it in B. Yeah? So this is how we're going to set this up. You did 0.06 times X. So for B, what's your percentage for B? 0.0575 times, what did we say, how much did I invest in B? 10,000 minus X. I keep doing that too many zero business. Question? Yeah. And from here, it's just solving. This one actually doesn't even have like factoring or any of that in there. So take a minute on your papers. Solve out this one. If you need a calculator, get a calculator out. Pretty much assume every day in this class that you will need a calculator and you will use a calculator. Lots of calculator use. Okay? So get a calculator out, do a little bit of solving. You do want to make sure that you do give the answer to the final question. They want to know how was it split up. Therefore, you want to know both what you invested in A and B. So you know A from solving for X because we said we put X in A. We find B by then subtracting. Did we do okay on the solving part of that? The setup's really what I'm trying to work through with you, and I'm trying to give a different example for all the types so that you're not headed off on homework and not having something to at least look at. Okay. Questions? All right, we're going to go to the last two then. All right, so the last two are examples 6 and 7. In example 6, they are redeeming bonds. They need, at the end of this, $1,102,500. Okay, they set aside $1 million right now to invest. Okay, now this is going to be, let's try to remember something from last year. Compounded annually. Does anyone remember these formulas? PERT is the compounded continuously. There was another compounded one that looked like this. Okay. That's a compounded annually formula. Anyone remember what P was? The term that it was principal, but it meant like what you were investing. R was your interest rate, and T was your time, which in this case is, 1 year at a time, right? All right, they are going to redeem the bonds in 2 years. So we're going to have to add in the fact that it does that again. But you can use these formulas for that. So what would be our principal or the amount invested? 1 million. I have to count my zeros as I do this. What is your A? Anyone remember what that was? That's what you want at the end. T is how many years, right? So how many years is this? 2. Okay. So that would be 2 years there. What are you solving for? R. All right, so let's look at what that would look like. Plugging in my numbers, let's see how we solve this. All right, so working backwards. I'm solving for R. What do I have to get rid of first? The 1 million, right? So the first thing I'm going to do is go ahead and divide. So 1,102,500 divided by 1 million. 1 with 6 zeros, yes. You get 1.1025 equals 1 plus r squared. What do you have to get rid of next? The squared. How do we get rid of that? You could FOIL. If you FOIL, you're going to make a mess out of it. Square root both sides. All right, when you square root both sides, quick memory of last year. When you square root a number, what do you have to put in front of it? Plus or minus. Now, in just a second, we're about to get rid of that plus or minus. Okay? Because does it make sense for an interest rate to be negative? No, it does not. Okay? So you can, if you can logically work through that right now, in your own head, drop that plus or minus. Don't just not do it, though. Always keep in mind that when you square root, you should plus or minus. Sometimes it will be that one that works. So just be careful with that. If I solved both of these for r, I would have 1.05 minus 1. So 0.05. I would have negative 1.05 minus 1. So negative 2.05 makes 0 sense, right? Get rid of that one. So what is our interest rate in terms of percentages? 5%. They need a 5% interest rate to get that money at the end. I know, not getting that right now. All right. Last but not least, one more. Then homework time, I promise. Okay? Last one. Another business thing that you tend to see is rent examples. So we're doing one of those as well. All right. This one We're gonna walk through it one piece at a time. All right. So rental units is another big thing that you're gonna see on and off with word problems with this. You have 96 apartments. Rent is $550 per month. Every apartment can be rented. However, if they increase the rent by $25 each month, there will be 3 apartments left vacant. Not like when you read this, you think like what's happened. It's really just if the rate goes up, less people are willing to rent with them. So a couple apartments will remain empty. They want to receive $54,600 per month from rent. What rent should they charge? This is something that businesses actually work through and say, if I charge this much, I might get half of them filled. If I charge a little bit less, I'll get all of them. Therefore, I make more money overall. It's actually kind of an important thing to be able to do. Evaluate the realisticness of your cost. So what we're going to look at here is an equation for total rent. Okay? Your total rent for your apartments is literally just your price per apartment times number of apartments rented, right? You have 96. There's no guarantee they will all be rented out, so you have to think about that and how much you are charging. What do they want their total rent to be? $54,600. Okay. The price per apartment, you immediately want to plug that in as that $550, right? But they are saying what rent should be charged. Okay. So if you charge $550, you can rent all 96. However, they don't quite get what they want for that. So the price per apartment is going to vary depending on what they decide. So how we are going to set up the price per apartment is a baseline of $550. What else did they tell us about the price per apartment? Okay, you can increase it $25 per apartment rented. Do we know exactly how many we're renting out? You can do up to 96, but we're not sure of all of them. So we're going to set it up as 25 per apartment. We'll call that X. All right? You are going to multiply that by the number of apartments rented. Are we renting all 96? Not necessarily. At a maximum, we're renting 96, but what happens if you increase it by $25? You take away 3 per, it says 3 vacancies with no filling, all right? So you are renting 96 minus 3 apartments. Every time you go up 25, you go down another 3 apartments. So that X on both of them says if I go up 25, I lose 3 one time. If I go up 25 twice, I lose 3 2 times. If I go up 25 3 times, I lose 3 3 times, right? What do you do when you have something set up like this? FOIL. Yay, foiling. Use your calculators if you need to. Because this is definitely large numbers. Once you FOIL to solve something that has a squared term in it, again, we went over this a couple minutes ago, you are going to need to factor. So to factor, you need to have everything on one side and it equal to 0. The way I'm set up here, which side should I move everything to? I'm going to move everything, for me, to the left. I don't like to factor things with a negative squared term. So I'm going to move the 75n squared to the left. Subtract the 750n. And I'm going to subtract the 52,800 from the 54,600. Now, I get right here, and this is not necessarily something I'd like to factor. What do you always look for first? Common factors. And in fact, all three of these do divide by 75. So if you divide everything by 75, you end up with something a whole lot easier to factor. What factors of 24 will add up to negative 10? Mm-hmm. So you get n is 6 or n is 4. Now let's just check. I switched to n's. I don't know why. That's just me. Anything that's an n should be, I do things in my brain sometimes. I'm sorry. N's, x's. That's true, but can be confusing. Jackson, it's a little scary you were with me. Very, very high level. All right. Either way, what was our x representing, or our n, since I switched? Apartments rented, right? That was the number of apartments that it would change based off of the price. What's the question?
What rent should be charged for each apartment?
What rent should be charged? Where am I going to have to find that still? This is where this line is real important to me. Which part of this is going to tell me what rent should be charged?
What did we solve for?
We solved for basically the change of apartments. If you add, so the 6, if I go back to x, or the 4, it's basically giving us, in a roundabout way, the number of apartments rented. So they're saying, if you did 96 minus 3 times 4, that's 96 minus 12 apartments. So if you rent out 84 apartments at a price of, plug in 4 here, 550 plus 100. So if you rent out 84 at a price of 650, they get the rent that they want. Alternately, you could also use this 6, 96 minus 3 times 6. You can rent a few less apartments. So 96 minus 18 is 78 apartments. But that would be at a price of, if I plug in 6 here, 700. So what we solved for was like the variable nature of the apartments. If you take out, or if you up your price by $150, you can rent fewer apartments, 78. If you up your price by only 100, you can rent out 84 of them. Either way, you get the same amount of money that you were looking for.
There's 2 answers on this one?
There is 2 answers in this one, yes. Either one would work. It would be different prices for different numbers of apartments. Basically, what you just found is that you'd like to charge somewhere between $650 and $700. That's giving you a range of prices. If you charge between those two amounts, you will get what you want. That's what you found. Okay? I would have just said between 650 and 700. That would have been my answer. I would like to find that, because here's the thing. Now, this is going to take you back more than you want to know, but someone asked the question, so here we go. This is a quadratic, right? So what you are actually getting from this, here's 4, here's 6. Essentially, you've got a quadratic that looks like this, okay? At 4 and 6, you're hitting what they've asked you, which is that 54,600. What you didn't really account for is if you find that perfect balance point in the middle, this vertex of the quadratic, you're really making even more money than they asked for. They asked for that just baseline, but you could go anything in between there and make that much money or more. So here is where an inequality may have worked a little bit better for this, because you could say it ranges between these two values, and it probably would have made more sense that way. I know that's more than some of you wanted to get today, and that's a lot of like word problems here. Also after chapel, and it's a Thursday. So I know we're there. This is why we're not doing the rest of the word problems today.